Okay, math teachers, here's a video for the fifth category in the fourth meet, trig mechanics, and this is the only category that we can have our calculator. First, let's refresh our memory on some right triangle trig. Let's say we're talking about this angle here in a right triangle. If this is the angle, then that's the opposite side. This is the adjacent side, and that's the hypotenuse. Sine is opposite over hypotenuse. The cosine of the angle is adjacent over hypotenuse. Tangent is opposite over adjacent, SOHCAHTOA. You may also come across a problem where you have a square root. If you have a square root in the denominator, that's not the simplified way to write it. 10 over the square root of 3 you have to rationalize the denominator by multiplying the numerator and the denominator by the square root of 3, and that comes out to 10 square roots of 3, and then the square root of 3 times the square root of 3 is 3. And if these numbers can reduce, the numbers that are outside the square root, then you would do that, but these two don't reduce. So 10 over square root of 3 comes out to be 10 square roots of 3 over 3. Also, some right triangle relationships. Remember, if you have a 30, 60, 90 triangle, if this is 60 degrees up here, the shortest side is A, the hypotenuse is 2A, and the other remaining leg is A times the square root of 3. Or if you have a 45, 45, 90 triangle, two of the sides are A, and the hypotenuse is A square roots of 2. It's the same. Yeah, these are the same. Just notice, try to remember the smallest side is A and the hypotenuse is 2A. Here I put it on its side. Doesn't matter how it's shown. I guess you can tell because of the 60-degree angle. That's the one that's A square roots of 3, and across from A would be the 30. We might do a problem where it says the angle of depression. Think of that as below the horizontal. And you may see something that says angle of elevation. Think about that as being above the horizontal. What else we have? We may have problems that have circular motion. Recall that 360 degrees is 1 revolution. Or it could be in radians. 1 revolution is 2 pi radians. I usually remember that because 2 pi r is the circumference of a circle. So there's the 2 pi. Oh, there we go. Distance around a circle. The circumference is 2 pi r. Now, sometimes you're going to be relating circular speed and linear speed. Circular speed is how fast it's going around, like revolutions, but that could also be in degrees, and it could also be in radians. That's circular motion, circular speed. And we could have linear speed, which would be distance. So if you're relating, well, hopefully we do a problem where it relates how fast it's spinning, and you got to figure out how fast it's gone, like a wheel going down the road. It might be spinning at a certain rate, like 5 revolutions per second. How much distance is that? Well, it depends on the radius of the circle, of the wheel. Okay, law of sines, c squared equals a squared plus b squared minus 2ab sine of c. The area of a triangle is 1/2 AB times the sine of C. Now often, if we have a right triangle, it's a sine of 90 degrees, but the sine of 90 degrees is 1. That's why you might remember, or you might recall, the area of a triangle is often 1/2 AB. That's true if it's a 90-degree angle, but if it's not a 90-degree angle, you can just put in that angle right here. The law of sines, there's a relationship between all sides. The sine of an angle divided by the opposite side equals the sine of another angle divided by the opposite side equals the sine of a third angle divided by the opposite side. Here's a conversion problem. This is related to this up here. Let's say you have to convert from 1,500 revolutions per minute, and you have to change that into feet per second. 1,500 revolutions per minute, and we have to get into feet per second. So what I'll do is say, okay, I need to 1 revolution. And how many? Oh, they tell us the radius is 4 inches. So 1 revolution, going back up to here, 1 revolution is 2 pi. 1 revolution covers this much distance, 2 pi r. So since the radius was 4 inches, 4 times 2 is 8 pi. So it's 8 pi inches for 1 revolution. So now I'm in inches, but I need to change to feet. So 1 feet, 12 inches. You want to have stuff that cancels out. What do I mean with that? Like, here's a revolution, 1500 revolutions, so I had to put revolutions in the denominator. And I converted it into inches, but I have to get rid of inches, so I put it down in the denominator. Now up in the numerator I have feet. That's what I want. So that one's all set. Feet's all set, but I got to get seconds into the denominator. Right now I have minutes in the denominator, so I need to move minutes up into the numerator so they cancel out. 1 minute is 60 seconds. Now you just multiply across. 1500 times 8 times pi times 1 times 1 divided by 60, also divided by 12, and it comes out to this. Wow, that's a lot of work just for the notes. Find the measure of angle B in the figure to the nearest degree. Since it's 112 on both sides, it's an isosceles triangle. You cut this right down here, and it cuts this in half. So this is 23. This is the right triangle, and we can use our graphing we can use our calculator because we have this angle here. If you remember, we have the adjacent divided by the hypotenuse is 23 divided by 112. That's the relationship between the adjacent and the hypotenuse. So toa, so that's cosine, so I want to go inverse cosine. Inverse cosine of that answer and get 1.36. Now what did they want us around to? Nearest degree. Oh, I'm in radians. Yeah, that's a good thing to check. I'm glad that happened. That's a good thing to check. We want to make sure we're in degrees. All right. Now go back to that. Go to the previous entry. Whoops, wrong one. I don't want to have to retype it all. Oh, didn't like it. All right, I'll try again. Shoot. 23 divided by 112 equals inverse cosine of that answer, 78 degrees. Wow, that took a long time. A cell tower is 100 meters high. A guy wire makes a 6-degree angle with level ground. Must be fastened to the tower 90 meters above the ground level. So right about here. A guy wire that makes 60-degree angle with level ground. So here's the level ground. So this is 60 degrees. And instead of 100, I should write, because all I care about right here is actually 90 feet. Wonder why they said it was 100 meters high. What length of wire is needed? Add 1/2 meter to each end to attach a cable clamp. What length of wire is needed? Add 1/2 meter on each end to attach a cable. I don't know why they wrote that part. Let's just figure out how long this wire is. We know this is 60 degrees. This is the opposite side, and this is the hypotenuse. That's sine, so the sine of 60 degrees will equal the opposite, 90, divided by the hypotenuse. That's what we're trying to solve for. So to solve for that, you can switch these two and get x will equal 90 divided by the sine of 60. 103 point. Give exact answer or round to hundredths. So rounding to hundredths. Oh yeah, this is a calculator round, so you should be able to round to 4 places unless it specifies. Since they specified you had to go to hundredths, that means we had to go to 2 decimal places, so 103.92. A wire is attached to a telephone pole, what's this, the same problem? just different numbers. If the angle between the pole and the wire, okay, this one's now saying this is 35. Angle between the pole and the wire is 35. How far from the pole on level ground is the wire secured? So they're asking, what's this length right here? We know this is 20 feet above the ground. I'm trying to solve for x. So I'm going to use, we always use the angle. This is 35 degrees. That's opposite, and that's adjacent. So this time I'm using tangent. Tangent of 35 degrees will equal opposite over adjacent. If I multiply both sides by 20, I'll have the answer. 20 tangent of 35. They want us to go to the nearest inch. Now that's pretty sneaky because I did it in feet. Let me just change. I mean, I could change. Oh, it's 14 feet, so I could go 14 times 12. That's like I was thinking I could just change the 20 into feet and then redo the problem, but 168. That wasn't too bad. What is the area of a triangular plot of land whose angles, if it's between two sides? Holy smokes. So this is 64, and this is 87, and this is a problem. I'm going to change that into a decimal. So decimal, you'd have to know that minutes, 84 degrees and 37 minutes. 37 minutes divided by 60, 60 minutes in a degree, plus the 84 degrees. So that's the measure of the angle in degrees. And then I would plug it into the law of cosines. You might say, what? Law of cosines. How far back do I got to go? Law of cosines right here. Actually, or do they want the area? Oh, they wanted the area. Cool. Area is right underneath this. 1/2 AB sine C. 1/2 AB sine C. 1/2 64. Why don't I just bring out the calculator and just type it in, save time. 1/2 times 64 times 87 times, what was it, sine or cosine? I forgot. I've been teaching math too long. Area is sine. Times the sine of the angle. Well, I already have the angle typed in here, so I'm going to use this function and get 2,771. What are they didn't say, they didn't specify what to round it in, so I need to go 4 decimal places. So technically I should write 2771.7206. And we have 2 more problems, but this has been, this angle of depression, tree snapped winds. Yeah, it looks like it's similar problems to what we've already done. So I'm going to end this video now. Or actually, if you want, there's a problem for you to do. You can click pause. I don't have the answer available to you though, and I don't want this video to be any longer. And here's another problem for you to do. You can click pause and give that one a shot. Okay, that's it for this video. Have a great day.